Raise the roof, roof, roof.
A second example problem for Newton's first law has a mass hanging from two cables. Okay. In the first example that I did, we had two cables, but one was attached horizontally, the other one was attached to the ceiling. Okay. In this case, both are attached to the ceiling, and now both create an angle. One example that I had done in class involved a traffic light. To make it easy too, we can leave the weight at negative 100 newtons, just like the last example problem. But a traffic light hanging from two cables, one forms an angle of 37 degrees, and the other one forms an angle of 53 degrees. Now I know this is not to scale, but I'm going to try to make the bigger angle here, the 53, and the other one, 37. And I want to know, once again, what are the tensions in the cables. I always like to start from the left and call this T1, call the other one T2. Okay. The next step is to form my table. I give more reasons in the first example, if you want to take a look back at that video, about how we actually get the components for the x and y directions of T1 and T2. So first I'm going to write my three forces, T1, T2, and the weight. Next, I'm going to write the x component and the y component of those tensions and weight. The easiest one is 0 for W in the x direction. All of it's pointing in the y direction. Okay. Now if we look at T1, change colors here to show the x direction. Okay. T1x points to the left, so that means it will be negative, and it is T1 cosine of 53. The y is vertical, and that is positive because it's pointing up, T1 sine of 53. From our angle, T1y is opposite and T1x is adjacent. That's how we get cosine and sine. In T2 we do the same thing. The difference in T2 is that both are positive, all right, and we have to change the angle here. So T2 we have plus T2 cosine of 37 and plus T2 sine of 37. Right. The table here makes it a lot easier. The difference between this one and last one is now we're going to have two equations that both have two unknowns in them. Okay. So in the first case, we are going to look at the sum of the forces in the x direction. In the second one, we're going to look at the sum of the forces in the y direction. I like to call this equation 1 and the y direction equation 2, just to kind of keep track of things. So first I'm going to add up all of my x components. So that is negative T1 cosine 53 plus T2 cosine of 37. I'm not going to write this 0 in this time. All right, and both of those add up to equal 0. And in the y direction, I have a positive T1 sine of 53 plus T2 sine of 37 minus 100 newtons equals 0. Now the first thing I'm going to do here is solve the first equation and I'm going to solve that for T1. Well, no, let's solve it for T2. All right. I'm going to erase some of my table here. Give myself some room. So that's really Newton's first law right there, getting those two equations. From now to the end, it's just algebra. Okay, and plugging values in, and we got two unknowns and we got two equations, so we could solve for both T1 and T2. All right, so I'm going to solve for T2 from the first equation. I will end up getting T2 is equal to T1 cosine of 53 divided by cosine of 37. Now I'm going to take T2 and I'm going to plug it into equation 2. So I'm going to substitute in T2. Right, this is where it gets a little bit messy. So T1 sine of 53 plus, now here's my T2 right here, T1 cosine of 53 divided by cosine of 37. I'm going to put that in parentheses just to remind you that that's T2. And that's nice. It actually was right under the substitute in T2. All right. Now don't forget the sine of 37. And I'm going to go ahead and equal that to negative 100 newtons. All right. So, oh, I said negative 100 newtons. It was a subtraction of 100 newtons. When I take it to the other side, it's positive. Now I'm going to factor out T1. So T1 times sine of 53 plus cosine of 53 divided by cosine of 37 times sine of 37. Now at this point, some students equals 100 newtons. Some students will actually see that if you bring the sine of 37 into the on top here by cosine of 53, sine of 37 divided by cosine of 37 is actually the tangent of 37. All right? So some students may like to do that. Others, maybe not. All right. So T1, I should make a note here too that at any point in time, if you feel like taking sine of 53 and cosine of 53 and actually using numbers, that's okay. You can do that. The reason I don't, I like to plug everything at the end, all right, to try to keep it as accurate as possible. All right. So T1 is 100 newtons divided by, I have to write this all out again, sine of 53 plus cosine of 53 sine of 37, all divided by cosine of 37. Okay, and the answer then for T1 would actually be 79.9. Now the nice thing is that we already solved for T2. And that's right here. Okay? So now I'm going to take my 79.9 for T1 and I'm going to plug it into T2. Let's use a black here so we can keep it different. So T2 is equal to 79.9 newtons times the cosine of 53, all divided by cosine of 37. Now when you multiply that out, you will actually end up getting 60.1 newtons. And those are your two answers, T1 and T2. All right. Now, some people, when they draw the picture, they may actually have T2 being on the other side with the 53-degree angle, and that's okay. It doesn't really matter. if you were to do that, your T1 would be equal to 60.1 and T2 would be 79.9. All right. So once again, follow the steps just like we did in the first example problem. You first have to, what I think, make a table. Use Newton's first law that says the sum of the forces equals 0. Add up all your x components, equal them to 0, which is right here. Add up all your y components, equal to 0. Choose one of the equations to solve for one of the tensions, and I choose equation 1, and I solve for T2. I substitute in T2 into the second equation, because that's how you solve when you have two unknowns and two equations. I found T1 to be 79.9. I plug that back in to something easy, an equation that was the easiest to find T2, and that's 60.1. All right, that's the end of example problem 2 for Newton's first law of motion. 2 strings, both hanging from a ceiling or hanging from 2 poles if they were holding a traffic light.